Ah, an empty cave. Perfect. Just what I needed. Whoa. Hey, I wasn't expecting to see anybody else here for this experiment. Excellent. What was that now? Stop the TNT? No way. I have to see what this explosion creates. Hey there, I'm happy to see you're still in one piece. Did you know when things explode, they go ka-boom? Yeah, of course you did. Everyone knows that. And we love it. Think about fireworks in your favorite action movie. Would that movie have been as fun without the protagonist narrowly escaping from a rampaging ball of fire? Not for me, and maybe not for you either. The explosion is just one tiny part of the overall lifetime of an explosive. Dynamite and TNT are two of the most well-known, thanks in part to Looney Tunes. I'm here to ask the big questions though. We know where an explosion comes from, this small, unassuming cylinder. Light one, and you better be hauling butt to get out of there. But where do explosions go? They expand vertically more than horizontally. Like, think about the thumbnail that you clicked on about a minute ago. Was your first thought, yo, why didn't this guy draw the explosion flat like a pancake? I doubt it. Explosions expand up, 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 and away. They go toward that other big fireball that's in the sky. Sky, sky, sky. What a funny word. It loses meaning if I say it too many times. And it's another word for atmosphere. The atmosphere is awesome. Catch me outside if you think any different. It protects us from the worst UV radiation. It keeps us from having wild temperature fluctuations during a day-night cycle. I love the atmosphere, and that's why I know it's mostly made up of nitrogen, oxygen, water, argon, and carbon dioxide. Yeah, I'm gonna kick argon out right here. It's not part of the point I'm gonna make by the end of the video, but remember these four. They are important. They are important because of their stability. Don't believe me? Well, then let's take a look at an alternate reality together, where a weatherman might say... Thanks, Cursory. Yes, we have a severe chemical blast sweeping from the north. The nitrogen buildup in Montana will be bonding with the hydrogen in Nebraska's airspace this weekend. Folks in Missouri, get your masks out for the ammonia along with your umbrella. Then, New Englanders need to watch out, because due to the summer heat, the rain coming down from Canada is reacting into hydrogen peroxide. Folks, you might want to be playing Wii Sports instead of going to the golf range this weekend. Okay, back to you, Cursory. Thanks, weather dude. Oh, hey, but don't forget, this scenario is fake. It is not real. I'm making the point that a weather person would never say stuff like that because these gases are pretty darn stable, at least compared to more sinister molecules, like the active ingredients in TNT and dynamite. These suckers are bad to the bone and they don't last long before they explode. It took humanity quite a bit of tinkering to figure out how to keep them happy enough to exist for practical purposes like mining. In order to do this right, we need a lab that is explosion resistant and airtight so that nothing can escape. Luckily, I got just the lab right here. And a couple of chemolists to do the analysis after the dirty work is over. I personally can't wait to get started, but some of you might want to know why TNT and dynamite are super crazy, super duper unstable to begin with. And to that I say, holy moly, thank you. That question is exactly what chemistry is all about, because chemistry is the science of understanding why stuff does what it does by studying molecular shapes and atomic identities. Cool, I went ahead and put my gloves on, grabbed a tiny amount of TNT and dynamite as a sample for us to look at. Huh? My hands look empty? No, I didn't grab a lot of sample because I didn't want, the stuff to blow up yet. Look, I'll prove it. There's a microscope around here somewhere. Okay, here we are. Yeah, there they are, and they're both powders. Riveting. A microscope is not a strong enough tool to see atoms and molecules. It's great for looking at cells in biology class, but what we need is something even stronger. So bye-bye microscope and hello picoscope. Let's dig right in and look at some molecules. The active ingredient in TNT is, well, TNT, which stands for trinitrotoluene. We're looking at the molecular shapes now. Those 3 nitro groups are huge. The molecule can barely stay together, the way the nitro groups treat each other like punching bags. The active ingredient in dynamite is nitroglycerin, shown here. All looks calm at first, but with a closer glance, yikes! For both molecules, every nitrogen atom is positively charged, while 1 oxygen per group is negatively charged. Why did I agree to getting this close again? Let's back away slowly and carefully. I'm powering down the picoscope and back in relative safety again. We saw how their molecular shapes were leading to instability. The reaction is imminent. It is coming. It cannot be stopped. Now, let's focus on the atomic identities to get a clear idea of what that mystery product might be. We've got access to carbon, hydrogen, nitrogen, and oxygen. Our product has to contain these 4 elements. Got any wild guesses? To the kaboom! Say it with me. 3, 2, 1. After the dust clears and a quick analysis, you are going to think I'm messing with you, but I'm honestly not. The nitrogen reacted together to make nitrogen gas. The carbon reacted with the oxygen to make CO2, and the hydrogen reacted with the oxygen to create water. These are the same species as the major components of the atmosphere. Mind blown. But not literally, thankfully. Wait a second. The alarm back at the lab is going off. What could possibly be going on there? Whoa. I wasn't expecting this. The explosion reaction was so hot that a secondary reaction triggered. Hey, I got an idea. How about we analyze this gas too? This is absolutely wild. The nitrogen and carbon dioxide that was originally created reacted together in order to make NOx and carbon monoxide. These gases are toxic. Caution, stay back. Exposure to them will make you think you've got the flu or have food poisoning hey, I don't feel so good actually. I think I'll use a sick day for the rest of the day. Sorry to leave so quick, but see you next time, and seriously, thank you for watching.